and welcome to today's webinar, Optimizing Curve Data Management. My name is Fred Poland, and I'm your presenter for today's webinar. Today's topics will include curve data loading, including a review of the various methods to import curve data into your project, such as LES import, import options, and GeoGraphix ASCII4 well file curve imports. Default settings covering default curve lists and curve aliasing, default parameters, data conversions, and units. Curve operations such as copy, delete, clipping, rescaling, filtering, interpolation, and curve normalization. Curve editing of template displays, both graphic and manual editing. Template editing including track management and editing. Importing test data such as core, deviation surveys, dip meter data, and curve aliases. Curve QC to cure your data prior to your interpretation. Now on to the demonstration. We'll start with importing logs into the project. So we'll go to the GVERSE petrophysics icon in the upper left. Import. And we have several import utilities. LES import, list-TIFF import, dlist import. Now this is single value, not array values. ASCII import, plus core data import, deviated survey data import, dip meter import, and curve alias import, where you can import your curve alias table from one project to another. We'll just go ahead and start with the LES import. Now the import utility dialog box pops up and gives you your list of LES files. Now this dialog box is made by Microsoft and has a limitation on how many rows of data you can have in here. So if you have a lot of LES files, you're best to use this import all LES files in the directory, which will take everything in that directory and import it. I'm going to do that. Next, the multi-well import dialog box displays default in automatic mode. Run Wizard and manual modes gives you the ability to be a little more customized, a little more granular on how you want to import things. Now I would refer you to the help files. They're very, very good in explaining all the functions and features of the import dialog box. So for our purposes and time, we'll go ahead and take the automatic mode import, finish. Now it came up with GRI 16 that had no corresponding ID in the well data base. But I do see that GRI 16 does have a well name that corresponds to this well right here. So I want to make an automatic, or I should say manual association. Associate those curves. Confirm that association. And now that drops off the list. This show all will show all of the curves in the project. Next, I'm going to import a well base ASCII4 format. So we'll go ahead and do that through a well base. Come up to the well base icon, import GeoGraphix ASCII4. Skip the choose DEFCON import. We do not have a DEFCON import because this is the first time we've imported. So click next. Browse out to your data file, GR17. WB4, that's a well-based ASCII4. I'm going to uncheck the perform bulk upload. Since we don't have a lot of wells, this is not necessary, and we're going to override all. So next, 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 and finish. Then we'll go to GRI 16 or 17. Notice there's a vector button here with the blue color. That means there's data behind it. So these are our data sets, our field data sets, and our import one curve set. And these are the list of curve mnemonics that came in. If I want to actually see the curve, I'll just select the curve in the row, come to the view well log, and I can now see a thumbnail sketch of the curves to make sure that the curves are looking good for QC purposes. Next, we're going to look at the default settings. That's under the project menu, default settings. The default curves is a list of your mnemonics for your default curves. These are curve names that are understandable by a human being, and then there are alias to industry standard or industry specific, or I should probably say vendor specific mnemonics for different curves. Now the hierarchy goes from left to right, so in this case for ResD, ILD would be the first one it looks for, and DI would be the last one it looks for. So let's go ahead and do an alias right now. So let's do it for ResD. Now ResD already has these curves alias to it, so we're going to go to the list, drop it down, and let's choose the ladder log, add it to the default list, and then we can change the hierarchy by highlighting it using these up and down arrows to change the hierarchy order. So now I see in ResD, there's the lat curve showing up right there. Next, let's look at the default parameters. These are constants that are used in various equations. These would be parameters that you could have a default value assigned to. So for example, for row M, we have a default value of 2.68 bulk density units. Conversions allows you to take different new input mnemonic units. Say you want to convert from degrees C to degrees F. If those import units are in the files, then you could use this scalar, this multiplier and offset, to then change from degrees C to degrees F. These are the different units you can associate with different parameters. And then, of course, the Data tab would allow you to limit the data for the entire data set. Next, we'll look at curve operations. So we go to the Curves menu, and under the Curve Operation group box, we find the Copy Curve, which will take an input either from field data or a specific curve set. And you copy it from one particular curve to, say, another curve. And you can filter that based upon a well list and a depth range. The Delete Curve dialog box will allow you to take one or more curves, add it to the delete list, and again you can filter it on wells and depth range. Min-max clipping, again you would have a default curve, an output curve, and then you set your minimum and maximum values. And again, you can filter that on wells and depth range. Rescale dialog box. Again, you take your input curve, your output if you want a new curve, and set a new value for the left and right scales here. Again, you can filter those on wells and depth range. Filter. Again, another import curve, output curve, filter length, and then filter it by wells or depth range. Interpolate, very similar, input curve, output curve, filter length, filtering on wells and depth range. Now for the normalization, we're going to go ahead and do a normalization for you. We'll first select the curve, and we're using a default curve, and so this is going to be gamma ray. Choose our reference well or wells. You can choose multiple wells if you want to, and you can look at a filter list if you want to cut down the number of wells to be considered. But we're just going to take GRI 6, just one well for our reference. So there's the histogram and the cumulative frequency curve. Then our list of import curve or output curves or normalized well curves. Again, you can filter those on a well list. But we'll take everything from GRI 7 all the way down to GRI 21. Now we do have the ability to do batch processing, where we can do all the wells all at once, where the computer actually tries to get the best kind of normalization. You can look at different methods, the average, single point or 2-point method. You have the ability to discriminate, so you have a bad hole, so use your caliper to filter out bad hole for developing your statistics only over a good hole and good well curves. Interval, so you want to filter out certain areas. You can come in here and you would filter. Now this filtering and discriminator is only going to be used for the statistics. It's not being used on the interval itself. When you do the output, it's going to be output from the grassroots to the TD of the well. Now I'm not going to use the batch processing. I'm going to be using it looking at individual wells. So we'll highlight GRI 7. Again, import one curve set. Import is the GR, the min, maximum value, average. Normalization methods. I'm going to be using the manual method, but we also have the average and single point method. Again, you have discriminators for, say, discriminating bad hole, and interval in case you wanted to filter out certain parts of the well to develop the normalization statistics. Now let's go ahead and add the crawl spot in here. And for the x-axis, I'm going to use the ResD. Now looking at the histogram here, the green curve, that's our input reference curve. The red curve is going to be our output curve. Right now it has not been normalized, so it's just going to look just like the input curve here. The input curve is in blue, and just for clarification, I'm going to take off the input curve and just look at the normalized curve. Now we have a Px minimum and a Py minimum, or I should say P max minimum. Right now they're set at P5 and P95. You can move those minimum and maximum P values around using the left mouse button. To change the value of the lower P statistics, use the right mouse button, and you can move it left and right and change the P value for the lower or the upper. Now grabbing it at P50 right here, I can then move it to the side, but I see I've got a second lobe here. So maybe I've got some other units in the well that I'm trying to normalize that is not in my reference well. So I'm going to come up here to my interval, and I'm going to change it to, say, from the C38 downward. And that seems to have filtered out something above this well that was changing the normalization pattern. That looks pretty good. Now the status is processed. Not until I save it is it really output to this field data set with the mnemonic GRI norm. Then I simply work down the list, and only as necessary will I actually adjust this. Save that. And so on and so forth. So that's the normalization method. Next, we're going to be looking at curve editing. We're going to start with graphical curve splice. So I'm going to open a well, GRA 21. And we're going to go to the Home tab and look at the Edit Curve Data for the input curves. So for import 1, I see I have a gamma ray, goes from 4231 to 6985. Input 4 has a gamma ray curve, and it goes from 6935 to 7989. So let's look around 6900 and see what's happening to the curves. Now we see we're actually running splice 1, but there's a flat spot here as you're going from import 1 gamma ray to import 4 gamma ray. So let's change the input here and go to the specifically import 1. And you see it tails off here. Now we're going to be adding the curve, the gamma ray from import 4, so we no longer need the caliper or the SB. So let's make this a little bit bolder so it's easier to see. And then we're going to add in the correlation track from import 4 the gamma ray, and change its color to say the green color. And you can see the overlap right here. So this is where we want to be doing the splicing so we can get rid of this little dead part of import 1 gamma ray curve set. So we'll go to the curves menu, go to the graphical curve splice icon. I'm going to add from import 1 gamma ray curve, change its color and its width, change that to red. And import 4 gamma ray. We'll change it to green. And then the output, we're going to change it to blue. Okay. Now we've got this slider here, and as we slide the slider up and down, it changes the splice point. So if we want to put it right up here, notice we no longer have a flat spot like we did initially. So slide it up here. If we like that, we right click and save it. We're going to save it to import 1. Now we can save it just for the one curve, the gamma ray curve only, or if we want to splice across all common mnemonics in the 2 different curve sets, you choose this radio button, splice all common mnemonics in source curve sets. Since it's just that one curve, we're going to stay with the splice and save this curve only. Then we're going to change the template. We don't need this one. Delete it. Then change this one to the spliced curve set. And now you see we're spliced from the top through the splice point to TD. Next, we're going to move on to template editing. So we're going to select GRI 8. And we're going to open up an interpretation set. An interpretation set is a set of log templates, crossplot templates, report templates, and UDEs that can be saved to a set name. So if we were to do, say, an Archie interpretation, we would then automatically associate an Archie interpretation presentation template, a picket plot, an Archie interpretation report, and then the Archie interpretation UDE. Now let's scroll down to where the action is. And go back to the Home tab. And we will turn on the formation tops. And we will limit the display to our zone of interest. There is the F11 right there. Now the first thing we're going to do is graphical curve and track editing. So if I want to make this Archie SW track wider, I just left click on the right edge and just move it interactively. If I want to change the position of this template, I can grab it in the middle, drag it over and drop it. Put it back. If I want to change the order in which these color fills are laid down, I simply click on one and then drag it above the other. So if you have curve fill that's covering over the curves themselves, you can just reorder the layering from top to bottom here. Likewise, if I want to move a curve within a track to another track, just click on the header, move it over and drop it there. Move it back. To add a new track graphically, I simply come over to the white space, right click, and add whatever type of track you want. Now there's about a dozen different track types. Again, I will refer you to the help files that gives good detail on each of these, but I'm just going to add a linear track. I can make it a little bit wider. Then to add a new curve, I just right click, go to new curve for track number 6, and the curve I want to put in is going to be SOPH. Change the right scale to 0.25, maybe make it a little bit bolder, and let's change it, say, to a blue color. And to change the name of the track itself, all I have to do is double click on the track header, and it either brings up the log templates property, and I can change it right here, or I can change it graphically by simply highlighting the name and typing something else like interpretation, and change it interactively. Now the log templates dialog box is accessed through the home, edit template, log, and we'll start here on the left side with the depth track. This gives you your vertical scale, where you want your thick, medium, and thin lines. Where do you want your intervals? Current is in MD feet, and you can also have secondary labels on here, and also the track width. Tracks is where you can add a new track of different types, and you can see the drop down gives you all the different interval types. Or I should say, gives you all the different track types. Curves, this is where you can add a curve to any track. Again, this is curve set independence, so you can use any curve from any curve set. Area fills is like what we're showing here for the clay, hydrocarbon, water, and matrix, where you would choose a left and right scale, and the type of free preview, which would be the type of pattern or color you want to show. And then, of course, data postings will allow you to put in any type of test data as annotations on the log. So we'll go back to the tracks, and we're going to change to the interpretation track. We're going to add a new curve in the curve track. Add from the field data. We're going to add V-shale. And maybe change the curve to a different color. And then OK. So there's our V-shale and SOPH. Again, if I want to change the order, just swap them and it changes the order in which they're laid down. So you can see now the V-shale is covering the SOPH curve. Next, we're going to import some test data. In this case, it's going to be curve or core data. Import core data. Now, this usually can come through like the spreadsheet import or an ASCII import, but in this case, we're going to do it for individual wells. We're going to do it for GRI 21, so we'll choose the ASCII file and slide down here to GRI 21. OK. Now here's the data file. It's an ASCII data file with the delimiter is either space, text, columns. Highlight the first line of data and then parse the columns so I can then give it the correct units. So depths in feet. Porosity, so that's going to be core porosity. Permeability, that's going to be core permeability, and then this is description, which will be in the remarks. Now sliding down, I see that the null values are 99.99, so we'll put that in here, 99.99, and then import. Next, we want to then show the core curves on the track itself. Now I imported the data into GRI 21, so let's select that well. And let's add the core curves to the core space porosity track. So right click, new curve, core porosity, and we'll change the scales to left is 0.25, and right is 0. Now core is discrete data, so it's not in the curve. So we're going to take the curve annotation off, and we're going to add a circle, make it size 2, and maybe make it an orange color to show. Click OK, and OK. Now notice that the core porosity is at the bottom of the hierarchy of the layering. So if I drag it to the top, now you'll see this core data showing up on top of the area fills. Next, we're going to QC our curves. So we're going to select GRI6. And notice now in the SP curve, there's a spike here that's not real. So we're going to do a manual data editing. So I'm going to highlight the SP curve in the header, go to the Curves tab, and go to the Data Patch tool, and simply click through here to edit out that spike. Now to save it, I just hit the display icon, and I save it, yes. Now the next thing we're going to do is do some simple depth shifting with some core data. But first we have to import core data into GRI6. So just like we did before, we're going to import core data, or GRI6, open that, hit the first line of data and parse the data into columns. The first column is depth in feet, then it's going to be K permeability, K max, and then porosity, core porosity, and then the null value is 999.99. Then select import, and here is our core data. But notice that core data does not line up with this block of sand right here. So we need to do a simple depth shift. So that's done in the Curves tab under Curve Editing, Simple Depth Shift. And it's not in a curve set, it's in a core data, discrete data, core 1. And we're going to move it up about 10 feet. So -10, apply, and that looks better. Then OK, and save it. Yes. Next, we're going to do complex depth shifting. To do that, we need to change our template. So go to Home tab, and we're going to open the template, and it's the system area. I want the raw curves, and we're going to remove this one. And we're going to slide down to about 6450. On GRI15. There. Notice that the SP and the gamma ray are not lined up here, but above and below the F11, they seem to be okay. So there's some kind of maybe stretching of the cable going on those different tools. So this requires a complex depth shift. So again, to the curves, complex depth shift. Our affected curve, in this case, is only the gamma ray. You can do multiple affected curves. In this case, it's only the gamma ray. So the base curve we're going to use is SP. That's going to be our standard. And then it's going to be a 100 or negative 100 on the left. And on the right scale, it's going to be 50. Now the shift curve is going to be the gamma ray. GR, again, the left is going to be 0, and the right scale, 150. Click OK. And notice that we have the SP in blue, the red is the gamma ray curve. Now to do the simple depth shift, I'm going to anchor it up here. Double click for a bar, I'm not going to move that bar. Now to do the shifting, I'm going to come down here, double click, and I'm going to look at the shoulder here on the red curve and the shoulder on the blue curve. Notice how the shifting is done on the template. Again, I'm going to double click right here, and that trough right there on the blue curve goes to that trough on the red curve. Double click again. The peak there on the red curve is the peak on the blue curve, and double click down here to anchor it again. So now everything lines up very nicely. We'll go back to the display, save it, yes. And now we have taken out the stretching between the gamma ray and the SP curve. The last QC method I'm going to show you is the SP baseline drift correction. So we'll select GRI 17 for this. And let's go to zoom to fit. Take out the caliper and the gamma ray. And you'll see you've got a drifting to the left here as you get deeper. That's a contrast between the formation water and the mud filtrate salinity. So back to the curves. Go to SP baseline shift. And we'll change the scales here. The left is going to be -100. And the right is going to be 50. Go ahead and click OK. Now this red line is the baseline, and it's really quite simple. All you need to do is click and move that baseline right over against the bottom of the SP curve, and it takes out the drift. You can have multiple points in here if you need it, but in this case I think really one would do. To save it, go back to the display, save changes, yes. And now if I go back and collapse it, you'll see that everything lines up very nicely. I hope you have found this webinar useful and interesting, and that it will help you with your curve data management and display efforts. Thank you for your attention, and see you at the next webinar.